Imagine a world where art, creativity, and innovation are not limited to humans. You walk into an auction house. You see a striking piece of art. Complex, intriguing. It's clearly the work of a true master. Bidding starts. The tension is palpable. It's a hot item, and the price quickly escalates. Bid now or forever hold your peace. Finally, the gavel drops. The piece sells for an incredible $432,500. But here's the twist. The artist behind this portrait of Edmond de Bellamy isn't human, it's AI. Yes, you heard right, a machine created this work of art.
Artwork created by artificial intelligence. What?
This groundbreaking sale at Christie's 2018 auction wasn't just a triumph for one piece of art. It was a statement that marked the arrival of generative AI on the grand stage of art and creativity. It stands as one of many other instances that reveal the limitless possibilities that generative AI brings to our world. But what exactly is generative AI, and how does it even work? From artistic expression to reshaping industries, how did it become this huge global phenomenon? Get ready, because we're about to embark on a journey through the fascinating world of Gen AI, exploring its mechanics, its many applications, and how it's revolutionizing the way we interact with technology and creativity. Now let's explore the magic behind generative AI. How does this technology craft masterpieces, compose music, or write captivating stories? Let's demystify this with a simple yet thorough explanation. Generative AI is a type of artificial intelligence that, at its core, is like a digital alchemist. It transforms data into new, unseen creations. From pictures and melodies to words, it learns from existing content and then generates new instances that feel like they belong to the same family. It can be contrasted with discriminative AI, which is another subset of AI and deep learning that doesn't generate new results, but classifies and predicts instead. Discriminative AI is great at tasks like email spam detection, image classification, and medical diagnosis, where the goal is to categorize data into predefined classes. Generative AI, on the other hand, is all about creating. Some of the most popular generative AI models include: Number 1, Generative Adversarial Networks, GANs. Picture GANs as two rival artists in a studio. One is a forger, the generator, trying to create a convincing fake painting, while the other is the art critic, the discriminator, trying to detect which paintings are fakes. The forger keeps improving, drawing from inspiration or data, until the critic can't tell the difference between the fakes and real artworks. This is the Gen AI model that was used to create the earlier mentioned portrait of Edmond de Bellamy. The generator made a new image based on a data set of 15,000 portraits painted between the 14th century to the 20th, and the discriminator tried to spot the difference between a human-made image and one created by the generator. Number 2, Variational Autoencoders, VAEs. Imagine VAEs as imaginative artists. They don't just copy a picture, they capture its spirit in a simpler sketch and then use this essence to paint not only the original picture, but also create a gallery of similar yet unique artworks. After training on a set of images, like thousands of faces, the VAE can generate new faces that look realistic but don't belong to any real person. It's like our artist who, after looking at many faces, can draw a completely new face that looks just as real. Number 3, Transformers. Transformers are a type of neural network architecture that can function as either generative or discriminative models depending on how they are trained and applied. They are not inherently generative, but they can be excellent generative models. For example, in natural language processing, a transformer trained to generate text, like OpenAI's GPT series, can produce coherent and contextually relevant paragraphs and stories, or even simulate dialogues. When in their generative form, imagine a transformer as a super smart librarian who's read every book in the library. This librarian, the transformer model, is really good at answering questions or even telling you new stories based on everything they've read. Just like how our librarian reads all kinds of books, the transformer model is trained on huge amounts of text data. It learns from every sentence, every word, and how they all relate to each other. When you ask the librarian a question or start a story, they remember not just the words you used, but also everything related to them in the books they've read. This is like the transformer's attention mechanism that understands the context of each word in a sentence, not just the word itself. In short, transformers work by absorbing vast amounts of text, understanding the context and nuances, and then using that knowledge to generate coherent and relevant text. The rise and success of generative AI, particularly in its modern form using deep learning techniques, was not fully anticipated to be as significant as it has become today.
I'm depressed.
Initially, the focus and major successes in AI and deep learning were mainly centered around discriminative models, especially in areas such as image recognition, speech recognition, and natural language processing. But let's briefly explore the history of generative AI, highlighting the key advancements that have led us to the amazing technology we have today. 1956, Dartmouth Conference. Often considered the birth of artificial intelligence as a field, the Dartmouth Conference brought together researchers interested in neural networks, cognitive science, and what would eventually become AI. While not directly about generative models, this conference was pivotal in establishing AI as an academic discipline. 1986, the backpropagation breakthrough. A pivotal year when David Rumelhart, Geoffrey Hinton, and Ronald Williams introduced backpropagation, revolutionizing how neural networks could be trained. This opened doors to new possibilities in AI. 2014, a year of milestones. This year witnessed two major leaps in generative AI. Diederik Kingma and Max Welling unveiled variational autoencoders, revolutionizing data interpretation. Ian Goodfellow and his colleagues almost simultaneously introduced generative adversarial networks, a groundbreaking model that creates highly realistic images. 2017, the Transformer. Ashish Vaswani and his team introduced the Transformer, a very crucial neural network design that leverages attention mechanisms to learn from sequential information, like language or speech. 2018, the GPT. Alec Radford and his team introduced the Generative Pre-trained Transformer, GPT. This is a big model that uses the Transformer architecture to create different kinds of text on different subjects. 2019, StyleGAN. A researcher named Taro Karas and his team introduced StyleGAN, an enhanced type of generative adversarial network that can create a wide range of detailed and realistic images, including faces, animals, landscapes, and more. This was a major advancement in image generation. 2021, DALL-E. Aditya Ramesh and his team created DALL-E, a powerful model that can create lifelike images based on written descriptions. In these milestones, we see a journey from theoretical models to generative AI capable of awe-inspiring creations, reflecting both immense progress and the exciting potential yet to be unlocked. Generative AI has been a really important technology trend of 2023. Many organizations are interested in it and want to know how it can be used. Here are some examples of how generative AI is being used right now. Content creation. Generative AI tools can create most types of written, image, video, audio, and coded content. For instance, one of the most talked about applications of generative AI in image and video generation is deepfakes. This technology uses generative adversarial networks to create realistic video and audio recordings. Some well-known examples include deepfake videos of celebrities.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not.
Or news anchors.
He's suggesting it came out of nowhere. What we subsequently learned is it may have come from the former president or his legal team acting in bad faith. This is a deepfake example of what is possible with powerful computer and editing. It took around 72 hours to create this example from scratch using extremely powerful GPUs.
In filmmaking, Lucasfilm used deepfake technology to de-age characters in the Star Wars series, like bringing a young Luke Skywalker to life in The Mandalorian.
He wants your permissions, but talent without training is nothing.
Generative AI is also responsible for de-aging Robert De Niro in the movie The Irishman.
I was just doing a job to make some extra money.
In music composition, the lead single Break Free from Taryn Southern's album I Am AI is a notable example of generative AI. Southern used AI tools to generate musical compositions, which she then developed into full songs. In gaming, Hello Games' No Man's Sky uses procedural generation algorithms to create an infinite, explorable universe, showcasing AI's capability to create complex, varied game environments. This vast, open-world space exploration game offers unparalleled freedom, allowing players to discover new planets, trade, fight, and survive in a constantly evolving universe. Its gameplay is driven by an algorithm that ensures each player's experience is distinct, with uncharted worlds and species to encounter. Similarly, the text-based adventure game AI Dungeon uses OpenAI's GPT-3 to generate dynamic storylines, allowing for an infinitely variable narrative based on player input. This game stands out for its ability to generate endless, open-ended storylines in response to any player input, offering a limitless range of narratives and scenarios. Unlike traditional games with fixed paths and outcomes, AI Dungeon provides a truly dynamic storytelling experience where the player's choices lead to completely unscripted and unpredictable adventures. Moving away from gaming and into writing and journalism, generative AI has been showcased in multiple publications. For example, The Guardian's 2020 article was written entirely by GPT-3, demonstrating the model's ability to generate coherent and contextually relevant text. Similarly, the Washington Post's Heliograph, an AI-driven technology, has been used to automatically generate short news reports, particularly in areas like sports and elections. Product development. Another fascinating area of application for generative AI is product development, which uses the technology to generate designs, prototypes, and simulations. For example, Airbus used Autodesk's generative design tools to create a partition for an airplane cabin that was 45% lighter than previous designs. The partition was not only functionally efficient, but also aesthetically unique, showcasing the potential of AI in aerospace design. Adidas introduced the Futurecraft 4D shoes, featuring midsoles crafted using a generative design and 3D printing. The process allowed for a highly optimized structure that could be tailored to specific performance needs and individual customer preferences. NASA has explored generative design for creating more efficient antenna designs for space missions. By using AI algorithms, they were able to develop unconventional designs that improved performance while reducing the weight and use of material. Code generation. Generative AI can suggest code completions as developers type, saving time and reducing errors, especially for repetitive or tedious tasks. GitHub Copilot is a great example of this as a tool that suggests whole lines or blocks of code as developers type. It's trained on a large corpus of code and can help in writing new code and understanding and working with existing code. This tool has proven invaluable for accelerating coding tasks, especially for boilerplate code, and assisting with language syntax and API usage. Customer experience. Generative AI applications are designed to enhance customer experiences by deploying customized and innovative content. IKEA's Place app is a great example of such a use case, as it helps customers visualize furniture in their homes before purchasing. While the core technology of IKEA Place is augmented reality, AI algorithms can suggest furniture based on the room's dimensions or the style of existing decor, effectively generating personalized interior design recommendations. Data augmentation. Generative AI can be used to generate synthetic data to train machine learning models, which can improve their accuracy and performance. Companies developing autonomous vehicles like Tesla use synthetic data to train their driving algorithms. Generative AI creates various road scenarios, weather conditions, and unexpected obstacles that might not be sufficiently represented in real-world data. Just as we've seen the amazing capabilities of generative AI, from making beautiful paintings and videos to composing music and optimizing product designs, it's time to think about its broader implications and the ethical dilemmas it comes with. As we step into this new realm of AI-driven creativity, we're faced with questions that challenge our traditional views on art, ownership, and ethics. This technological advancement blurs the boundaries between human-made and machine-generated content and brings us to a critical point where the lines of copyright, ownership, and creative rights are not just blurred, but are being redrawn. Once again, the portrait of Edmond de Bellamy mentioned earlier remains at the center of this debate. The controversy surrounding this artwork reflects the intricate ethical landscape of AI-generated art. The collective called Obvious, responsible for this piece, received criticism from the AI art community when they admitted to using code from 19-year-old AI artist Robbie Barrett. This situation raises questions about intellectual property and collaboration in the field of AI. What does it mean to create original work when the tools are communal and the output is based on shared technology? The ethical issues of AI in art go beyond legal matters and spark debates about creativity and originality. There are questions about AI-generated works. Can AI algorithms truly be creative, or do they simply remix existing human art? This is a big concern for human artists' livelihoods. The emergence of technologies that can clone voices and use deepfake techniques poses a significant threat to acting and creative expression. Actors are being pressured to give up their image rights indefinitely for AI use, raising concerns about the future need for human actors, especially in background roles. This situation leads to a broader worry. As AI shows the ability to create art similar to human efforts, there is growing concern about the devaluation of human artistry, challenging the unique value and irreplaceability of human creative expression. What ethical challenge in generative AI concerns you the most? Let us know in the comments below. As we look towards the horizon, generative AI is set to further revolutionize not just art and creativity, but a vast array of industries. Its influence is growing rapidly, as highlighted in McKinsey's 2023 Global Economic Impact Report, suggesting a potential addition of up to $4.4 trillion annually to the global economy. This significant boost will certainly redefine the way we work, especially in knowledge-based professions. What industry do you think will be most transformed by generative AI in the next decade? Share your thoughts down below. Beyond improving work productivity, generative AI is poised to revolutionize decision-making and teamwork, automating parts of jobs in education, law, technology, and the arts earlier than anticipated. However, this technological evolution brings its own set of challenges, ensuring fairness and diversity in AI training, strong data protection, and the ethical creation and usage of AI content are critical concerns that must be addressed. As we navigate this uncharted territory, the question becomes, how will society adapt to and use generative AI? The way we answer this will determine how this technology develops and affects our world. As we conclude our journey through the evolving landscape of generative AI, it's obvious that we're on the verge of a new era in human creativity and technological innovation. From the insane art auction of Portrait of Edmund de Bellamy to the wide-ranging possibilities in different industries, generative AI is reshaping our world in ways we're just beginning to understand. So, what do you think? How will generative AI shape our future? Will it enhance human creativity or overshadow it? How do we balance innovation with ethics? Share your thoughts in the comments below. Every AI masterpiece and innovation, there is the technology powerhouse that makes generative AI possible on a larger scale. Companies like NVIDIA, with their chips, are the foundation for training and deploying these generative AI models, and they're earning trillions of dollars with this technology. If you are curious, watch our latest video right here. If you've enjoyed this deep dive into the world of generative AI, don't forget to hit the like button, share this video with others, and subscribe to our channel for more insightful content. Your support encourages us to explore and bring more fascinating topics to you. Until next time.